We're going to be looking today at a feature of Entity Framework Core and something that's kind of come of age in Entity Framework Core version 8, which is just going to be coming out this month. So I'm going to demo on the release candidate, not the official release, but I don't imagine there'll be any changes. But it's a nice feature, although it does possibly lead to some bad coding if you don't get it right. And it's all to do with a terrible thing called an SQL injection attack that I'm sure you've heard of, been around for years, and we're going to see what those are all about and how this new feature can help with them, but also maybe cause problems as well. So what I've got here is a pretty simple web API application, and if I run this up, then we can see we've got a lot of endpoints, but basically we've got a collection of books, and each of the books, as well as an ID, you can see has a title, an author first name and an author last name. And those are all just being stored in an SQL-like database that we can see there. And then we've got some endpoints to access all of that. And the two bits of code that I'd really like to highlight are what we've got here. These two functions where we've got by author last name interpolation and by author last name formattable. And if we look at those two functions, we can see that they look very, very similar. There's some subtle differences. One is that here we're calling a method called SQLQuery, and here we're calling a method called SQLQueryRaw. And you can also see we're getting a warning on the SQLQueryRaw, which we'll talk about when we come to that. And also one really subtle difference, you'll notice here where we're doing the interpolation, so where author last name equals curly braces name, that one doesn't have single quotes around it, and that one does. And we'll see what that is all about as well. But the really big, important difference between these two is this one is susceptible to an SQL injection attack, and this one isn't. And this is why I find this feature a little dubious, because those two so much look the same. It should be really obvious if you're doing something that might cause an SQL injection attack or not. It shouldn't be a subtle difference. But let's begin by seeing what an SQL injection attack is. And so if we go back to having this application running, as well as being able to get all the books, you can see I've got a number of different ways of getting hold of a book by the author last name. So if I go into this first one and try that out, and if we put in Austen and execute that, then you can see we get back the two books we've got in our database by Jane Austen. But if we look at how that's been coded, we can see what's happening in here. So there we've got the one by concatenation. And what that simply does is says select star from books where author last name equals, and then we have a single quote, which is part of the SQL. Then we put in the name, which is that parameter Austen that came in, and then we have the close single quote. And if we take a look at the generated SQL, pretty obvious we're getting that, so that's just being logged. So select star from books where author last name equals Austen. Perfectly fine. But that is the heart of an SQL injection attack, because what a hacker can do is something like this. Rather than typing in Austen, they could type something like X, single quote, semicolon, delete from books, semicolon, dash, dash. And if we execute that, we don't get any response. But if we now take a look at everything that we had in there, we find that the entire database, or that entire table at least, has been deleted. And if we take a look again at the console, we can see there was the command that was issued to do the delete. And what's happened is, because it simply added that text together, so we've gone the select star from books where author last name equals, and then matching on X, but then that's my close quote, semicolon for a new statement, delete from books, semicolon, and then dash dash is an SQL comment, which means that very last close quotes, which is the one that we actually had on there, doesn't confuse it in terms of syntax. So we have been able to inject whatever SQL we like in there, because that is working with string concatenation, and so whatever we wrote gets through there. And that is the essence of an SQL injection attack. And although whoever is doing the hacking has to think about this a little bit, they've got to understand what the structure of the database is, what the name of the table. That's what hackers are good at, and they will get all that information, and then that certainly decades ago was the cause of lots and lots of really bad hacks. Most people know about them now and really avoid them, but they are still sometimes out there, and you will see these causing problems. There's actually a secondary problem there as well. Let me just repopulate the database. So I've got this generate just because I knew I was going to delete everything, so that will now mean that we've got everything back in there again. But you'll notice that in this list of books, I've got some by the author Patrick O'Brien. And the thing about that is he's got an apostrophe in his surname, which could well be confused for a closed quote. So another problem you get, which isn't actually an SQL injection attack, but it's a side effect of the same sort of thing, is if I type O'Brien in there and execute that, we actually get back an error. And the reason we get an error, again, if we look here with all that error, but the problem is that it's taken the apostrophe as the close quote, so we're searching for an author last name of O, and then it's just plonked Brian on the end of that, and so it can't make any sense. So if you do this string concatenation, you've got two problems. You've got the threat of the SQL injection attack, but also you're limiting what you can actually do your query on. Now, it's also the same if we use string interpolation. So if we just go back to what we've got here, I've got another one of these that says by author last name interpolation, and this one does select star from books where author last name equals, and then rather than adding on the name, we use string interpolation because we've got the dollar there, and so that will insert the text. But once again, and this is where we're getting that warning that I'll mention in a bit, once again we're getting the same problem, that it will just put in there whatever text we write, and so we're still prone to the error. So if I go to the GUI and go for that one by interpolation, and let's not do the delete, but let's just do that O'Brien and execute that, once again we get back the error and it doesn't know what Brian is. So string concatenation, string interpolation, both of them are prone to SQL injection attacks because they simply take all the text that was received from the user, who might be a hacker, and they just stick it all together, and the hacker can make some of that text be interpreted as actual SQL, not simply as a parameter. How is it that we would normally fix those? Well, the way we traditionally fix those, there's two ways we can do it. One is simply to have a parameterized query. So here we've got by author last name parameters, and what that does is it does the select, but then it puts, rather than the actual text straight in there, we just have this at name, so at is the syntax to indicate that this following is a parameter, and then we provide the parameter separately. So here we've got this new SQLite parameter, and so that name is what we put in there, and then that name is the actual value that's coming in. A little bit of a problem there, because I'm using an SQLite database, I've got to have an SQLite parameter. This means this code is not particularly flexible across other databases. You can fix that with some kind of factory, but I'm not going to worry about that here. That'll just be enough to work. But the point of that is, it doesn't just stick the text into the SQL. And so if we run that one up and go for that with parameters, and if we type in again our O'Brien, that gets us back the O'Briens, and if we look in here, we can see it's done things slightly differently. It's just sent off that query with the parameter still as a parameter. So it's never trying to put that text into the SQL. And in fact, once that reaches the database engine, the database will process the SQL part of it before it even inserts that parameter. So there's no risk of that happening at all. And so it works with just that one like O'Brien, but it would also work if I tried to do a quote X semicolon delete from books dash dash. If we execute that, all that does is it tries to search for something where the name is all of that, doesn't find it, but it hasn't actually treated that as SQL. So if now we take a look at all of the books, we can see they're still there, and so that's been stopped. You should probably have some other code in there that's trying to identify the attack so that you can see where the attack's coming from, that sort of thing, but at least we've prevented it in that way. So that's one way of doing it, a traditional way using parameterization. The other way, which is the way that I'd most normally use, is to use LINQ to entity framework, because here we have that same thing as a LINQ query. So from B in books, where b.authorlastname equals name, select B. And that also automatically does this parameterization. It also generates the SQL as well, but it does the parameterization, and it gets around that problem of us having a particular type of parameter, the SQLite one in that case. So also, if we run that up and go for the via LINQ, once again, if we try that out, put that in as O'Brien, we get back the O'Brien, and if we look at what's been output, we can see it's very, very similar to what we had when we wrote the SQL. The only difference is it's individually named the columns rather than using a star, but apart from that, it really is pretty similar to what we had. So parameterization works in the same sort of way. And that's actually one of the features that's come in with Entity Framework that allows us to use interpolation for parameterization. So let's take a look at that. And let's just, if we go in here, look at what we mean by that. So I'm just going to go to, let's just do this in the first one of these, just somewhere to put some code and talk a little bit about string interpolation. So I can say something like int x equals 100. I can say string s equals hello. And then I could do something like var interpolated equals $, and then x is x, s is s. And if we just put a break in there and run up to that point and just execute that one that we put it in, doesn't matter about the details really, but what we can see is we get x is 100, s is hello, and that's an interpolated string, which we've had for quite a while in .NET. But if we do things slightly differently, we can change that behavior, because what we can do is, rather than having that as a var, which is coming back as a string, we could have this as what is known as a formattable string. And you can see that's working perfectly well. And it looks almost exactly the same, but the point about a formattable string, if we run that up, and just go in there, now if you look at that, we can see, although the toString is still saying x equals 100, s is hello, if we look inside it, we can see that it's got this format, which is just the original string with curly braces and 0 and 1 in there, and it's got two arguments, and if we look at the arguments, we can see we've got the 100 and the hello. So a formattable string has all the information that we require in order to form the final string with interpolation, but it hasn't actually done the job. So it's still keeping the parameters separate from the actual format of the string, which is really exactly what we want to do with SQL. We want the SQL parameters to be separate from the body of the SQL that's doing the work. And so that's the trick that's used with these formattable strings. So if we then go to the ones down here that we had, this one, if we look at this SQL query and look at the parameter type there is one of these formattable strings. So when we pass in that interpolated string, it doesn't immediately calculate that it's going to end with author last name equals O'Brien or whatever. It is going to just send that interpolated string and use that to produce a parameterized query to do what we want to do. So if we run that one up and go down to by author last name formattable and try that out, and again put in something like O'Brien and execute that, we get back the O'Briens, and we can see that once again it has sent a parameterized query. So it's done really exactly the same as it did when we parameterized the query for ourselves, so when we had this one here, but it's done it in a somewhat neater way because it's just used the formattable string to pass in that information separately, and that all works fine. So that's really quite neat. But then we hit this, what I think is a slight problem and could encourage programmers to make a mistake in a way, because as well as the SQL query, which is the one that takes the formattable string. We've also got the SQLQueryRaw, and that just takes a string. And there we have the problem, because if you pass a string in there, our formattable string actually gets turned into a string, and so the insertion of that name text is done, and then we send that all off. So if I run that one up, and we go for the name by interpolation, and we do a try it out, and again, let's just put in the O'Brien, we get the error again, and if we look at the output, we can see that it's done the O, and then put in that quote and the Brian, so that's not working. So that one is just as prone to an SQL injection attack as the one we had up here, where we were actually concatenating them together. And that's where I see there's a problem here, because those two statements look so similar. We are getting a warning, but I'll come back to that. The only other difference, though, apart from the query and the query raw, is in this one we need the quotes because we're forming up the string. This one we don't need the quotes because it understands that that's a parameter. Now, a really bad way to have done this, which they certainly didn't do, would have been just to have the one method SQL query and overload that for both the string and the formattable string. Then it would have been really invisible as to what's going on. But even so, those are quite similar. And although it does give you this warning, if I were to just change this slightly to say string query equals, and then take all of that and put that in there, and then put the query in there, we now don't even get the warning. It can only give us the warning if you're immediately putting the interpolated string into that parameter, and then it says, well, hang on, if you've got an interpolated string, surely you wanted to use the query, not the query raw. But if we just separate it out a bit, now we're not getting any warning at all, but this function, as we saw, is still prone to the SQL injection attack, and we're getting nothing to warn us, and it is so subtly different from the perfectly safe one that we've got down there. I just worry that this will encourage people to think that that is always going to be safe, and therefore we're going to get SQL injection attacks returning. If you stick with LINQ, then it's not going to happen, and that's what I normally do. But there are situations where you can't perhaps get exactly the SQL you want with LINQ, and so you need to do this sort of direct coding. So just be very careful about it, because these two bits of code look so similar, and it seems to me that you could easily think you're writing safe code like this when you're writing very dangerous code like that. So that was an interesting feature, but one that might have some problems in that the good code and the bad code look so similar. People might be encouraged to write code that's once again prone to SQL injection attacks. There's lots of other features in .NET 8 and C# 12 just coming out this month, so over the next few videos we'll be seeing more of them, hopefully some more positive ones. But if you like that one, do subscribe, do click like, and I'll see you next time.